In this video, we'll be solving applications using right-angled trigonometry. These are some of my favorite problems in Trig. A lot of with Trig, we're learning new stuff and we're practicing skills, but I really like the application problems because then we're actually doing something with these skills that we're learning. So our general approach, our steps to solving an applied trigonometry problem is you want to start with a sketch. This is really important for us. Make sure that we have all our angles in the right spot. So draw a sketch and label it with the given information. Label the quantity to be found with a variable. Then you're going to use the sketch and our definitions of our trig functions using SOHCAHTOA to write an equation relating the given quantities to the variable, and then we'll solve our equation and check that our answer makes sense and include any necessary units since this is an application problem. To find the distance RS across a lake, a surveyor lays off side RT to be equal to 53.1 meters, with angle T being 32 degrees 10 minutes and angle S being 57 degrees 50 minutes. We want to find the length of RS and we'll round our answer to the nearest hundredth. Although my picture looks like there's a right angle there, there is no proof by picture, and you're going to find your diagrams they're not always to scale. So we have to prove that there is a right angle before we can use our right angle trig definition. So we were told that our side RT is 53.1 meters. We were told that our angle T is 32 degrees 10 minutes, and our angle S is 57 degrees 50 minutes. But like I said, we have to prove that angle R is a right angle. So how can we do that? Well, if angles S and T add up to be 90, it's going to force angle R to be 90. So you'll notice that the measure of angle S plus the measure of angle T does indeed equal 90 degrees, so we can conclude that angle R is a right angle. But you can't just assume that. You always have to prove it. And on a test or something like that, I'm going to want to see something that shows that you proved that you had a 90-degree angle there. Okay, great. We got our 90 degree. We're trying to find the length RS. That's this over here. And we want to use one of our trig functions and SOHCAHTOA. If I use angle T as my reference angle, side X is opposite and side RT is adjacent. Oh, opposite and adjacent, that is our tangent function. So we can say that tangent of 32 degrees 10 minutes is equal to our opposite side, x, over our adjacent side, 53.1. And now we solve for x. Multiplying both sides by 53.1, we get x to be equal to 53.1 times tangent of 32 degrees 10 minutes. And now we just need to plug that into our calculator and round to the nearest hundredth. Make sure you are in degree mode. And we get x to be 32.40, and our unit is meters. Next, we want to find the altitude of an isosceles triangle having base 184.2 centimeters if the angle opposite the base is 68.73 degrees. We'll round our answer to the nearest hundredth. Well, the first thing I would do is I would draw an isosceles triangle. Remember that an isosceles triangle has two sides that are the same. So it's going to be these two sides that are the same. Says that the base of this isosceles triangle is 184.2 centimeters, and our angle across from that 68.73 degrees. We want to find the altitude. So now we have to go back to geometry and remember what the altitude is. The altitude is the height of the triangle, so it would be this right here. And with an isosceles triangle, the altitude, when you drop it, makes a 90-degree angle with the base. A couple other things that are unique to the altitude of an isosceles triangle. The altitude is going to cut the base perfectly in half. So this half is going to be 92.1, and it also cuts the angle opposite the base perfectly in half. So it's going to make this angle 34.365 degrees. And what we're trying to do now is find the height here, the altitude. Okay, I'm going to draw a breakout triangle because I feel like my diagram's complicated looking. So I like to draw breakout triangles that just includes the information I need to focus on. So I've got a right angle with a base of 92.1, an angle of 34.365 degrees, and I'm trying to find this side x. Now we want to use one of our three basic trig functions to relate this one angle and two sides. So from our angle 34.365 degrees, we have the side that is opposite and the side that is adjacent. So opposite and adjacent tells us that we want to use tangent. Tangent of 34.365 degrees is equal to 92.1 over x. And we want to solve for x. X is currently in the denominator, so we'll multiply both sides by x to get it out of the denominator. That gives us x times tangent of 34.365 degrees is equal to 92.1. And then lastly, we're going to divide by that tangent. This gives us x equals 92.1 divided by tangent of 34.365 degrees. We'll put that into our calculator and round to the nearest hundredth. That gives us that x is equal to 134.69, and our unit is centimeters. In our next examples, it's going to involve angles of elevation and angles of depression. The angle of elevation of an object seen by an observer is the angle between the horizontal and the line of sight from the observer's eye to the object. The object is going to be above the observer's sight. So if you're looking straight ahead originally, and then you have to look up at an object, your angle of elevation is how much you had to look up from normally looking straight. The angle of depression of an object seen by an observer is the angle between the horizontal and the line of sight from the observer's eye to the object. The object is going to be below the observer's eyes. So same idea, you're looking straight ahead and then you look down towards an object. The amount that you had to tilt your head down from normal is your angle of depression. To measure the height of Lincoln's caricature on Mount Rushmore, two sightings 800 feet from the base of the mountain are taken. If the angle of elevation to the bottom of Lincoln's face is 32 degrees and the angle of elevation to the top is 35 degrees, what is the height of Lincoln's face? We'll round to the nearest hundredth. So the first thing I'm going to do is start with a diagram. So I'm going to draw Lincoln's face. All right, he had a big chin, huh? Okay, so this is going to be, I'm thinking straight down here. And then observations were taken 800 feet away. The angle of elevation to the bottom of his face is 32 degrees. And the angle of elevation to the top of his face is 35 degrees, and it's that whole amount. And they want us to figure out the height of Lincoln's face. So we have to figure out how we would do that with the information that we're given. Now, the ground we're assuming is perfectly flat and that we're going straight up to Lincoln's face. So we do have a right angle down here in the corner. But all we're trying to do is figure out what this amount right here is. What we can do to figure this out is we can figure out, so if we look like we got this blue triangle here, right? And then we have a red triangle as well, but I'm going to do it in green here. Notice that the height of Lincoln's face is the difference in the height of those two triangles. So we are going to find the height of the blue triangle, then the height of the green triangle, and then subtract that. All right, I'm going to do a couple breakout triangles here. So let's start with the blue triangle. We know that we have an angle measure of 35 on the bottom, a length of 800 feet, and we're trying to find that height. I'll call it x. From our angle of 35 degrees, we have the opposite and the adjacent side. So again, we're going to be using tangent. Now, you don't always use tangent, but you use it a lot. I think more so than the other two combined. So tangent of 35 degrees is going to be x over 800, multiplying both sides by 800. We get x to be equal to 800 times tangent of 35 degrees. I would wait. I would not get a decimal approximation here. I would wait until we get the two different heights and just put the whole subtraction in our calculator at one time rather than rounding early. So now let's do the green triangle. And I got a breakout triangle here, and I'm going to call this side y, not to be confused with the x above. Angle of elevation, 32 degrees, base 800 feet. From that 32 degrees, again, we have the opposite and the adjacent side, so we'll be using tangent. Tangent of 32 equals y over 800. Multiplying both sides by 800. We get y to be equal to 800 tangent of 32. Okay, so to get the height of the face, we're going to do the height of the blue triangle, which was 800 tangent of 35, minus the height of the green triangle, which was 800 tangent of 32. And we'll put this into our calculator and round to the nearest hundredth. You should get that Lincoln's face is going to be equal to 60.27 feet.